Deep in the Pacific Northwest, 6 brave members faced the challenge. Through successes and failures, they persevered and accurately collected the data they needed to accomplish the mission. Our experiment idea was to build a flight data recorder using low-cost electronic kits to collect valuable and accurate data during the balloon flight. The flight data recorder, or FDR, is able to record temperature, barometric pressure, GPS, altitude, latitude, and acceleration of the balloon. We can therefore understand more precisely how the balloon traveled and what the climate is like at the edge of space.
The first test was conducted in a clinical laboratory. By using an ultra-low temperature freezer, the flight data recorder components were tested under sub-zero temperatures. The FDR battery stopped working at minus 37 degrees Celsius. The solution was to insulate the battery with foam for thermal protection. Under normal room temperature, the battery was tested and able to sustain about 3 hours of flight time.
The second test was conducted in a field at a public park. This was the first flight test of the FDR and a simulated balloon launch. The flight capsule was tied to a bundle of small helium balloons. A kite string was tied to the balloons and sent to an altitude about 500 feet. The data recorded from this launch was very fascinating. We were able to see the flight track by uploading the GPS data to Google Earth. Both capsules were packed and ready to be shipped to the launch team.
We were very grateful to know that the balloon successfully launched on Saturday, August 10th, 2024, in Anderson, Indiana. After the capsules were returned to us, we immediately inspected the capsules for any physical damages. We did not find any damages or loosened parts. We removed the microSD card from the flight data recorder and downloaded the log file to a computer. The FDR recorded 2,021 records of data with an interval of 5 seconds each. In other words, the total recording time was 2.8 hours. At first glance, we were extremely happy and believed that the FDR had recorded the complete flight.
However, after a detailed analysis of the data, we found that the FDR stopped recording 8 minutes after the balloon blasted at an altitude of 93,457 feet.
From the data analysis, we can see the relationship between barometric pressure and barometric altitude. We can depict the true story of when our balloon was launched, how it traveled, at what altitude and geographic location the balloon blasted, and how fast it dropped from the highest attainable altitude before the parachute was deployed.
We were not able to record the true ambient air temperature using a temperature probe placed inside the capsule. Although we drilled some holes on the capsule, there was insufficient air circulation. Also, the electronics inside the capsule generated heat. The temperature probe was actually measuring the inside capsule temperature. The lowest outside temperature was recorded at minus 40 C by the launch team. This matches with what we anticipated in one of our hypotheses about external temperature.
Our patch design is circular, to remind us that there's always more to learn about our planet. Like a circle, the opportunity to learn is never ending. We wanted it to be evident in our patch that there was importance in the details. Everything in it has a meaning, even down to the colors of the sunset behind the balloon. If awarded, we would use the prize money to provide our cadets more hands-on AE opportunities, such as museum tours, STEM kits, and flight simulator excursions. We also would use a portion of the prize money on better recruiting equipment and general squadron operations and needs.
The High Altitude Balloon Challenge has been an amazing experience and has taught us a lot about weather, programming, GPS, and high altitude balloons. Through the successes and failures of assembling, testing, and data collection, we have grown both as a team and as a squadron. On behalf of Paine Composite Squadron, we thank you for this amazing opportunity.